Okay, so these are hopefully helpful tips for you for doing calculations for experiment 1, determination of measurements. So a couple things that you want to notice is the measurements that you would have had to have taken. So you have 2 beaker measurements, and then you have 2 unknowns, so you identify what those ones are. This is beaker 1 plus the unknown, and determine the mass of just the unknown. You would subtract the combination of the two and then subtract the mass of the beaker to get 5.5 for 1. And this is measuring it with the second beaker, so notice that the masses are slightly different. The other thing is the same for the second object. You'd have the combination of the mass of the beaker plus the unknown and then subtract the mass of the beaker. And then you do the same thing for a different balance. Notice that the values again are slightly different. For part B, you're just looking at volumes. Make sure you have the right number of uncertainty digits here. For part 4, you are measuring the mass. This is our number 4 in part B, measuring the mass of 25 mils, a 25 mil graduated cylinder, which for me was 29.979 grams, and then the mass of a 50 mil beaker, and I took the water temperature to be about 22.4. And then the mass of the 25 mil beaker plus 10 mils of water was this, and then this is the mass of the 10 mils of water in the 50 mil beaker. From the water temperature, I could figure out the density of the water at this temperature, which was in Appendix F, and that came out to be 0.99770 grams per mil. These are measurements from Part C and D, and then also I have measurements for Part E. So notice in between here I calculated the mass of the water, and that was just the mass of the combination of these two, the beaker plus water, and then you subtract the mass of the beaker. So my mass of water here was 9.799 for the graduated pipette and was 9.857 grams for the volumetric pipette. Then I have the density here, or part of my density measurement. So I had the volume of water in the graduated cylinder by itself, and then the change. So the total volume here is 1.13 mils, and for the other object was 2.14 mils. So to move on to calculations for part B, these are going to be the same for part B and C. So the process is the same, you'll just have different values. So again, I first want to calculate the volume that was measured in the graduated cylinder. So the mass of my 10 mils of water will be equal to the mass of the cylinder plus water minus the mass of the empty cylinder. So that will be the 40.964 minus 29.979 grams. So you can go back and look at the beginning part of the videos and see where I got those numbers from. But again, that's the mass of the cylinder plus water minus the mass of the empty cylinder. Again, that will be 10.985 grams is the mass of my water. To determine how much volume that actually is, to calculate that, you have density equals mass of the water over volume of the water. The density we got from Appendix F, so again that was 0.99770 grams per mil. And that's that's equal to 10.985 grams, which came from here, over the volume, which is what we're solving for. So you would end up multiplying, if this is the wrong calculation, you should multiply this over to here, and then it would be 10.985 divided by 99770. Oh, that's still the same. I did do that right. But here, if you notice, there's 5 significant figures, so my value should have 5 significant figures. So the volume here will be in mils, and that's the water. So to calculate the percent difference in the two measurements is the observed. This is what you thought you measured out, so you thought you measured out 10.0 mils, minus what you just calculated, and it's the absolute value of that over your calculated. So this would be 10 mils minus 11.010 divided by the 11.010, and then you multiply that times 100 to get the percent. So again, this is absolute value, so my number is going to be positive. I have 3 significant figures here, and this will be 3 significant as well. So that will be the 9.17%. So the calculation or the process for this is going to be the same for part C with the graduated pipette and also the volumetric pipette, and you'll do the same thing for the beaker. So it's just the same couple of calculations over again. The other thing would be the density calculation. So that's part E. So density equals mass over volume. That's in grams. Oops. And volume is in milliliters. So to determine the density, you look at the mass of your first object. I have to go back here. So the mass of I'll just go with this mass here. So of object Q was 5.541 grams. And the density that was displaced by Q or the water, sorry, was 1.13 mils. So that was by Q. So the density I have 1, 2, 3, 4 sig figs here, 1, 2, 3 here. So my numbers should have 3, so that's 4.90. The units are in grams per mil. So that's how you would do the calculations for density.